We're going to be talking about charge, discharge, and state of charge as it relates to SimpliPhi products. This is a very debated upon subject, as lithium iron phosphate batteries have a very flat discharge curve, especially in the middle, and same as it goes to charging. They kind of sit at one voltage for a long time. And this is just not the same with lead acid batteries. So we're going to talk about a lot of differences here, compare the two, and we're also going to talk about our products and how to choose the right one for your application. All right, so we were founded in 2010 as OES Energy. We actually began by making mobile power packs. We were producing custom batteries for Hollywood filmmakers. We eventually moved into military and emergency response applications in addition to residential applications, which is our main focus nowadays. But the military and Department of Defense just didn't want to give lithium batteries a shot. They felt like there were too many safety hazards and just articles in the news of lithium catching fire. Now, after asking them to simply just try it out, just test our products and put them through the ringer, they took them to Aberdeen Proving Ground and really were able to ensure the safety of our products. So that's kind of where we started in the Department of Defense. We've been expanding our product line, coming up with more versatile products that are geared toward installers, what we think installers want and what homeowners are looking for, always with the homeowner and the installer in mind. We're trying to make our products at scale now as we are ramping up our manufacturing capacity in our Ventura County, California location. We use only lithium iron phosphate chemistry. As I've mentioned, there are many safety advantages, and you can watch our other presentations if you want some details on those advantages. We use only cylindrical form factor, as there are lifespan advantages, performance advantages, safety advantages, and it is the most energy dense of the other form factors out there. An overview of our products before we jump into kind of the unique content related to charging and discharging. So you have a background is our PHI batteries. This is our bread and butter, our main, product we've been selling for about 10 years now. It's a 3.8 kilowatt hour battery. It's got 151 amp hours at 24 volts, or we've got a 48 volt option, much more popular nowadays, 75 amp hours at 48 volts. This is a very simple, tried and true, very rugged battery. It's made for parallel connections only, not series connections. It's modular and scalable, so meaning one person really can carry and install this battery all on their own. It's a small building block of 3.8 kilowatt hours, so you don't have a lot of excess waste in your system, energy storage that you're not using. For example, you don't have to buy the blocks in 10, 14 kilowatt hour blocks, something like that. You can buy a customizable small amount of storage at a time, carry it in yourself, even if you were a one-person installer. This PHI battery is most commonly used for lead acid replacements. It's compatible with a wide range of existing equipment, even older equipment like Midnight charge controllers, Outback charge controllers, even those FX or even MX, charge controllers, a lot of very simple devices that doesn't need communications. This battery has no external communications built in. It's going to operate very similar to a lead acid battery. You're just going to program set points into the charge controller and voila. It's got an internal BMS, of course, and additionally a circuit breaker on top for not only ease of installation, but a little bit of added protection, making it a little simpler maybe for you to meet the code requirements. That I find is a really nice feature of our batteries that I don't see elsewhere. Our 12 volt battery, actually just got a remodel. This is now coming with a breaker and terminals instead of these wires you see poking out. This is offered in 12 or 24 volts. Again, only parallel applications, not for series wiring. It is about 33 pounds, and I can't unmute you. So if you have your hand raised, just ask a question, and I can answer that as quick as possible. 33 pounds. This is really designed for mobile applications. I've got a couple of these getting ready to throw them in my camper van here. Compatible, again, with a wide range of charge controllers and inverters. Because of the lack of communications with this battery, it makes it a bit simpler, a bit more widely applicable. And of course, it's got an integrated BMS and now has a breaker as well. We've got access units. These are increasing in popularity. Really, as the code requirements are getting stricter in places like California and New York, we see all-in-one 9540 certified UL listed products being really demanded, right? So it used to be that you could kind of just do what you wanted. Now it's getting really strict. People are sometimes even in certain jurisdictions having trouble installing products indoors at all. And I've heard of many installer groups who simply say we only install outdoors because it's easier, and we only install 9540 products because of the permitting, how it streamlines permitting. So this is becoming increasingly popular as it's outdoor rated, it's able to be AC or DC coupled, comes with an industry-leading inverter, already built into the cabinet, mounted and pre-wired up. So all you've got to do is toss the batteries into the cabinet and make those DC connections. The 80 amp input breaker is going to kill the positive output. Good question. All right, nominal voltage of 51.2 volts DC still on our SimpliPhi battery. So this is essentially the same as our Phi battery. However, now we've integrated communications into the battery. So think same size, it's going to fit in all the same cabinets, same weight and dimensions, but now we've added an additional layer of protection and intelligence really through the BMS. The BMS is going to communicate in a closed loop fashion with certain inverters. Right now, that inverter is the Solarc inverter or the SMA Sunny Island inverter. Now, the advantages here are, first off, the communications is going to allow your customer to see a high level of accuracy in terms of state of charge, voltage, as well as charge and discharge, amperage at any time. I find customers are almost always wanting a battery monitor installed with their products. So this eliminates the need for that battery monitor as it's internal to the BMS. It's going to show the state of charge through the Solarc's LCD screen, or the same with the Sunny Island, as well as their respective online monitoring platforms like PowerView. You can connect up to 75 battery modules in parallel. So notice here there is a limitation on the scalability of the system because the battery communications lines, there is kind of a max distance there that they can accurately receive communications over. This is not the case with Phi batteries. So with our standard products, you can actually scale as many as you want in parallel. I've seen systems of over 100 Phi 3.8 kilowatt hour batteries. So we're talking over 400 kilowatt hours. Meanwhile, really rare to see a system of that size. I think most of you here on this webinar, seeing your names, I don't think you're going to run into that issue anytime soon. Hey, I hope you do. I really hope you do. But the 75 battery limit is a pretty rare limit to kind of bump up upon. Now, on the smaller end of things, another big advantage here is flexible sizing. So a lot of you kind of gripe and moan about our sizing requirements, saying, why do I need to size accurately to this 8 kilowatt inverter? The customer's only using 4 kilowatts. Well, the PHI battery isn't able to limit its own discharge as far as you're going to need a properly designed system. Right? So with the SimpliPhi, it's going to communicate to that inverter to limit the inverter's discharge rate. If that inverter, for whatever reason, doesn't respect the demands, it's going to also internally have an added form of protection against discharging and charging too quickly. In addition, last but not least, it's going to have cold weather protection, so it will not allow you to charge it below freezing when you're paired with a communicating inverter. Again, it's going to tell that inverter to kind of damper down the charge, and if it doesn't listen, it's going to open circuit internally. So it's a much stronger, more intelligent BMS that's got external communications as well as added internal protections as well. Yes, Jose, that's correct. SimpliPhi has a BMS that has communication, and the others do not have communication, but all of our products do have a BMS. John, I'm not sure if you could use a signal booster for the comms cable. I do not think that is an option here. Charging characteristics. So here's where we get into the fun stuff unique to today. I wanted to talk about mostly how to understand state of charge of a lithium iron phosphate battery. Our batteries are rated, Our batteries are rated at C/2 for discharging and charging. So this means a 3.8 kilowatt hour capacity, divide that by 2, and that's the rate you can discharge or charge at, which is 1.9 kilowatts. You can do the same thing in terms of amperage. So in a 75 amp hour battery, divide 75 as the capacity by 2, and you've got your discharge rate or charge rate of 37.5 amps. Here's the respective charge and discharge rates of the other batteries as well. And some considerations when you're, looking at this same thing with SimpliPhi is remember that the SimpliPhi has the same charge and discharge characteristics, but it can limit its own charge and discharge by communicating. So you don't necessarily need to size your inverter size your battery bank to fully power your inverter if you're using SimpliPhi. Another thing to keep in mind when we're talking about charging is multiple charge sources. So if you've got an 80 amp charge controller and 3 batteries, that's totally fine, right? There's no way your charge controller can charge those batteries too quickly. But if you've got a 8 kilowatt inverter with a generator charging as well at the same time, then it's going to be charging too quickly. So multiple ways you can combat this. You can use overcurrent protection. You can use settings like global charge, making sure the whole system is all communicating to not charge the batteries too quickly. And I like to think of it in terms of system design. So I really am a fan of the SolarArc inverter, putting everything in one box. That SolarArc isn't going to charge the batteries faster than 9 kilowatts, 185 amps DC. No matter if you have the generator running and the PV at the same time, it's all in one box and it all knows what's going on. So that's how I like to think of this. Again, if you're using PHI batteries, you need to make sure to program the charge and discharge rate into the system. But if you're using the SimpliPhi battery, this is actually going to program itself, even if it's undersized. So it's going to program the inverter's charge and discharge rate for you. Pretty much covered this as far as charge controllers. You can program the discharge rate, or excuse me, the charge rate very easily. It's extremely accurate. Whereas an inverter charger, you can program the charge and discharge rate on some of them accurately. Others, you may not be able to, rely on the charge rate being super limited. Some of the older and much cheaper inverters won't be able to have a programmable charger. SimpliPhi battery, again, is going to self-program that Solarc or Sunny Island charger. Now, AC coupled systems, we've found they don't always communicate between the battery-based inverter and the microinverters very well. So first off, make sure you've got these checked. Make sure you're talking to both inverter manufacturers and that they agree the firmware is up to date, the system is compatible. Secondly, make sure you have your AC PV array sized properly so it doesn't overcharge the batteries. So you don't want to have, a giant AC coupled PV array with nowhere to send its energy but the batteries. The batteries get full and the battery-based inverter tries to tell the microinverters to, calm down, slow down charging, and they just can't respond quick enough and they overcharge the batteries. This is something we've seen. This is why it's really important to size your AC coupled PV array to match that C/2 charge rating of the batteries. Just answering a couple questions here, the SimpliPhi batteries communicate with only two inverters at the current moment. That is Sunny Island SMA inverters and Solarc inverters. That's it. They do not currently communicate with Victron equipment. We're working on that. All right. So as far as charging with a charge controller, this is my favorite way to charge a lithium battery. It's very accurate in terms of charging voltages, charging currents. It's able to be extremely customized and limited. You can limit the amperage easily through the charge controller, and that's really, really reliable. You won't have to question whether that's going to work quickly or work effectively. One thing to note is understanding, a full charge and voltage reading correlation. When are your batteries actually full? I notice a lot of people will finish the absorb charge stage after 6 minutes at 56 volts, and their batteries will still be taking in a significant amount of current during the float stage, then afterwards at 54 volts. So to keep in mind here, the best way to know when your batteries are completely full is when the charge current has tapered off to 2% of the amp hour capacity. That is how to entirely top them off. You don't want to go all the way until they're accepting zero current. That's kind of just going to overcharge them, not going to enable them to last quite as long. You definitely don't need to float charge. So float charging, I really only recommend it when you're using, a renewable energy source and a charge controller. I definitely wouldn't recommend using float charge to leave your generator running to float charge the batteries. That's just a waste of energy, and they don't need a float charge. They certainly wouldn't mind a float charge, but it's not necessary. As far as using rebulk voltages, this is another kind of debated upon voltage trigger here. I think rebulk is super important if you want to keep your batteries full all the time. Maybe it's a backup system. You don't really cycle it too deeply, but you don't want to, you want to make sure it's full when you need it. That's the most important thing to you. I like to set my rebulk voltage high, like 52.5 volts on those systems. Whereas if you're cycling a battery daily, you're doing a semi-deep cycle on it, maybe 50 to 75% per day, you're going to want to set your rebulk voltage around 51.2. That way you won't be just constantly triggering a charge. Every time you trigger a charge cycle, you're going to do a little bit of additional wear on your battery. So of course, that will maximize your battery life and keep your state of charge relatively high. When we're talking about charging through an inverter, note that there's really no need to float charge. Again, I would disable that. It's kind of just a waste of energy. 56 volts at 5 minutes. It's the same charging parameters. It's totally the same. Whether you're using AC coupling, grid charging, or a generator, it's totally the same. And it's the same if we go back to the charge controller. 56 volts at 5 minutes is our absorbed charging. Another important thing to keep in mind is, does the inverter manufacturer actually warranty for lithium iron phosphate batteries? Or excuse me, just lithium ion batteries. And additionally, some customers use external chargers as well, just something that plugs into the wall and takes 120 or 240. The disadvantage here is these just are not perfect, right? They're made for occasional use and not designed for, repeated use of these chargers to maintain your batteries. All right, so we talked a lot about charging. Definitely going to cover discharging as well. Going to just pop into the Q&A. What about charging using a Morningstar TS-60 PWM with the latest firmware update? So charging parameters will be loaded into the TS-60. Our batteries really have no problem with a PWM charge controller. The charging parameters that come with the TS-60 aren't going to be ideal for our batteries, so you will need to just program them. Just program the TS-60 as you would for any other battery. Don't use the preloaded lithium setting. Just use our settings, but they're definitely compatible with the TS-60. All right, moving on. This is our 48 volt discharge curve. It shows resting state of charge versus voltage. I'm gonna say that again. This is not resting state of charge, excuse me. This is state of charge versus voltage at a very fast discharge rate. So this is a 2-hour discharge rate. I want to move on to a different graph that's a lot more helpful, which is this one. Let's just forget that last slide altogether. So here we have 100% state of charge, at between 53 and 54 volts, you can tell is where the battery will kind of just rest when there's no load on it. As soon as you apply a large load, so let's look at the C/2 discharge rate first. That voltage is going to heavily drop, right? So it maybe drops to 52 volts, then it's going to stay very, very steady, not even reaching 51 volts until you're at 30% state of charge remaining. So it's extremely difficult to look at the voltage of this battery and know how much capacity you have left. In addition, let's look at a different discharge rate. So let's say you're discharging a lot slower, C/5. C/10 or 20 is actually going to look very similar to the C/5 curve. But as soon as you put that load on the battery, it's going to drop and maybe rest around 52.5, 52.7, 52.8, something along those lines. And again, staying very steady and this time not reaching 51 volts until less than 20% capacity remaining. So again, between 100% and 20% capacity, it's so difficult to use the voltage to determine how much energy is remaining in your lithium iron phosphate battery. Now, this is an advantage and a disadvantage. Disadvantage just meaning you can't use voltage to determine state of charge accurately. The advantage being there's a lot of energy remaining in these batteries. They're sitting at a higher voltage throughout their discharge curve, and they're powering any sensitive electronics at a very constant and stable voltage. The point being here is it's really helpful to get a battery monitor that's going to act as a fuel gauge and show you the percentage capacity remaining at any specific voltage. If we look at a lead acid battery, it's a pretty flat curve. Excuse me, not flat. It's a pretty straight line here. It's going to go almost straight down. So when you compare it to lithium iron phosphate, when you make that switch, it's definitely confusing at first. And going back here to detail one more thing, you notice after we reach 20% state of charge, the voltage does drop off much quicker, and same at the very beginning. So that's why this is often so confusing. People see a quick drop and a quick drop, and they don't understand the flat middle of the curve. All right, so let's talk about discharging. Again, same discharge parameters for the batteries as charge parameters. This is actually meant to be 57 amps for the newest 12-volt battery. My apologies there. But we're looking at C/2, just discharge for all of our products. Again, with SimpliPhi, it can communicate that discharge rate to any, compatible inverters. However, when it comes to discharging as opposed to charging, there are surge capacities built into these batteries. Talking about 80 amps DC at 10 minutes. So for our 3.8 kilowatt hour battery, note that the 24-volt battery and the 48-volt battery have the same surge amperage. So realistically, this means if you're starting a motor or a large saw, something along those lines, well pump, you're going to want to go with 48-volt batteries as they have a larger surge in terms of power. Realistically, in a residential scenario, I have not seen any customers that really need C/2 discharging. No one is discharging their batteries fully in 2 hours in a residential scenario. That's really rare unless you're doing grid tied backup only for those brief power outages on a large house. One thing that a lot of installers tend to do is, in the past at least, we've seen people undersize systems and then use overcurrent protection to try to keep the batteries from discharging too quickly. Now, I would not recommend this. I always recommend using overcurrent protection, but I would do that in addition to sizing the system properly. And here's why. Let's do an example. We've got two batteries and they're 48 volts, so their max continuous discharge is 37.5 amps each. This is 75 amps total. And to do this, to protect the batteries, we're going to use a 60 amp breaker. We'll explain this a little more in detail as we go on. But first and foremost, when I see 60 amp breaker and each of those batteries have an 80 amp surge for 10 minutes, there's almost no way that you would be able to utilize your surge protection, your surge capacity, if you have a breaker on the branch specifically to limit the continuous discharging of the battery. So I think that overcurrent protection should be used for protecting wires, not batteries. However, let's just move forward with the example. You pick a 60 amp breaker, and why do you do this? Why is this an issue, right? So this breaker at 60 amps, it's going to trip when you're at approximately 120% of its rated capacity. So 120 of 60 amps is 72 amps. So that's just about perfect. And it's going to take almost 500 seconds to trip. So that's about 10 minutes right there. Now we move on to this different type of breaker, and we see that it's going to trip at exactly 100% of its rated capacity. So you got a 60 amp DC breaker, it's going to trip right at 60 amps. And then this fuse, it's not going to trip to almost 150% of its rated current. 150% of 60 amps is 90 amps, so that's not really enough protection for these batteries if you're not sized properly. So this is why, using overcurrent protection to protect your batteries is not a great idea. Realistically, any of these would probably be fine for protecting a certain size wire, but in terms of protecting batteries, you really want to size the system properly in terms of battery to inverter ratio. All right, and another important thing about discharging is understanding that knee. So we talked about how after 20% stated charge, the voltage does begin to more rapidly decrease. Once you hit 48 volts, and you'll notice it's very stable as you're approaching that 48 volts, but once you hit it, man, does it drop off fast. It's like it hit a cliff and jumped right off. It just is very quickly declining in voltage after that. And then you're drawing more current because the voltage is lower, and it just gets worse and worse. The way to prevent this, realistically, we recommend stopping discharging at 20% state of charge remaining in your batteries. This would be about 50.2 volts, but does vary depending on the load. So we recommend setting your low battery cutout to 50.2 volts. If you've got to set it to 48 volts, then simply make sure your delay is very short on that cutout. Another thing you can do to prevent, hitting this knee hard is starting a generator when the voltage is beginning to drop. So, for example, most of the newer inverters on the market right now have an option to add an AGS or an AGS built in. That's going to automatically start your generator. You can use that to start your generator, let's say about 50.4 volts or 50.6 volts to prevent it from ever reaching low battery cutout. You can also ask the inverter to pull from the grid when the battery reaches that voltage. That is another good option if you're grid tied. Now, I want to actually go back here for one more explanation is if you do end up hitting this low battery cutout and your batteries tank in voltage, the BMS is going to cut out. So what you'll have to do to reset that, sometimes you can simply just cycle the breaker on the battery for 15 minutes, turn it off for 15 minutes and then turn it back on and it's ready. Now, unfortunately, if you have done this repeatedly or done this, to a extreme extent and you cannot reset the battery on your own, what you'll need to do is order an external charger. So something that plugs into the wall and provides power without even seeing voltage. What happens when you try to recharge a dead battery with an inverter charger or charge controller is that startup current just to turn on the inverter or charge the capacitors within the inverter or charge controller, that simple startup current will draw down the battery again to BMS shutdown because it has so little energy remaining. And then in order to combat that, like I said, you need an external charger. It provides power to the battery without ever seeing a voltage on the terminals. All right, so how does all this relate to state of charge? One other thing that comes to mind is resting state of charge. So we did talk about how voltage relates to load when you're discharging the batteries. We did not talk about how voltage relates to load when the batteries are resting. So when the batteries are no longer in a state of charge, there's no load connected, they're really going to sit around 53.3 volts at a full state of charge. And again, give or take maybe a half of a volt. So it's hard to tell. But I find 53.3 volts signals a completely full battery. Now, as you move through a discharge cycle, and say you've got a battery at 50% state of charge, but now there's no load on it and it's just resting. How are you going to tell where it's going to be sitting? Well, I like to refer to this C/5 curve. So it's going to be obviously above 52 volts at 50% state of charge with no load. So realistically, it's probably going to be sitting somewhere around 52.5 volts with no load. And yes, we're talking about 16 cell batteries. That's what we're making over here. 16 cell lithium iron phosphate batteries. It's also going to vary if you're looking at a different chemistry or a different number of cells in the battery. Moving through here, we have really talked about all of this, rebulk settings, generator grid set points. One thing we didn't touch on yet though is selling. So if you want to maximize the amount of power you're selling, it's important to actually mess with this and kind of tinker with these settings a little bit. So let's say your customer, they just want to maximize the amount of energy they're selling. They don't really care to make sure that there's the most, 100% state of charge in their battery as they prepare for a power outage. They just want to maximize the amount of money that they're getting from the utility by selling power. I tend to say set sell a little lower on these type of customers, maybe 52.5, 52.4. It's going to draw the batteries down to maybe 70 to 80% state of charge, but you're going to sell the most that you can. Whereas on a customer who simply wants to keep the batteries full, 100% state of charge for a backup outage, but wants to sell at least a little bit of power, I'd say set this higher, maybe 53.2, 53.5 even. You definitely want it to be below the float voltage. For the best of both worlds, 52.8 is the general recommendation in most of our guides. But again, this is something you might want to mess around with a little bit. Last but not least, before I answer any remaining questions, I want to talk about our Elite IQ Installer program. This is really designed to bring additional business and exposure and a display of expertise to our existing battery installers. So if you've installed SimpliPhi products in the past, or you're doing it right now, then I'm talking to you. What you get as an IQ installer, in addition, you get a spot on this map. So when customers are looking to get our batteries installed, they come to us and we point them to this map and we show them who are the nearest installers to them. We also send out email newsletters to anyone who has already subscribed to our newsletter. They get photos of your installations on a monthly basis. So we've got a lot of opportunities for promotion here. In addition, we're definitely going to be sending you some swag, some free merchandise, some gear. We're going to be hosting trainings for your team if that's of need for you. We've got senior level support available specifically to IQ installers in addition to our standard support line. But again, this is geared toward our existing installers, bringing you really leads looking for installs in their area. If you'd like to apply today, you can click on this link. or simply go to simplifypower.com/IQ, or email me. My email is on this next screen here. So training@simplifypower.com. Get in touch with me. Send me a couple photos of your installs, and I'll get you through the program, get you some free sweatshirts, water bottles, all that good stuff, and I'll get you added to the map. All right, so it looks like we're all done. I'm going to go ahead and hop into the Q&A section. Thank you guys for joining today. And again, email me if you need NABCEP credits at training@simplifypower.com, and include your full name as you want it to appear on the certificate. What's the best method to monitor or measure capacity loss of the batteries over 5, 10, 20 years, etc.? So the best way to measure capacity loss would be to get a battery meter, like a Victron BMV 712, for example. This is going to tell you exactly how many amp hours have gone in and out of the battery bank since your last full charge. So if you've got a 100 amp hour battery bank, and after charging fully, you calibrate it to 100% state of charge, 100 amp hours, and then after reaching 48 volts, the battery monitor says, oh, you've still got 20 amp hours left. Then realistically, that means your capacity is only 80 amp hours at that time. Does that make sense? Let me know. The 3.8M. The 3.8M is now the new model of the 3.8. It is just the same internals with a new case. It is definitely compatible with the 3.8, 3.5s, and 3.4s. However, the terminal spacing and locations have changed slightly. So if you got batteries on a bus bar that's like direct to terminals, you're going to want to switch to wiring if you're adding a 3.8M to the 3.8 with the plastic case. Let us know if you've run into this issue, and we'll see if we can work up something special for you. Are you going through UL 9540 with any of the inverters you mentioned? We are not going through UL 9540 with the Sunny Island, but we already have it with the SolarC. So we've got UL 9540 with both Amplify or Phi with the SolarC inverters in a ton of different configurations. You can use boss cabinets, you can use access units, you can use the batteries and the inverters alone. So there's a ton of different configurations with UL 9540. And we've also got it with Schneider and Phi, Schneider and Phi products. So we've got a ton of different UL 9540 configurations. Just email us if you need any advice there. Another question here. Many RV owners have trimetric battery monitor as well as trimetric charge controller from Bogart Engineering. Can those 12 and 24 volt batteries that you mentioned for mobile applications be easily installed with trimetric equipment? Yes, definitely compatible with trimetric equipment. I actually have seen Trimetric's battery monitor is better than some. It isn't the best when it comes to our batteries. I really recommend that BMV by Victron. It's just super accurate with lithium iron phosphate, but the Trimetric is definitely compatible, and it'll do the trick to an extent there. I will be sending out the presentation recording in a link to all the attendees and all the registrants. It might take up to 48 hours though, so please be patient. Have you gone through UL 9540A testing for higher capacities and closer spacing than what is in NFP 855. Yeah, actually we have. We've got UL 9540A test report. It's completed, and we're able to provide it to whoever needs it. If your jurisdiction inspector, whoever needs it, we can send it over to them. It does allow for closer spacing. I don't remember exactly what that spacing is, and there's a lot of specifics there about which side you're on, rear, front, etc.